Good morning, good afternoon, depending on where you are. Thank you and welcome to the Media Analytics webinar this morning. As I've mentioned before, my name is Yuti Alaten and I'm going to talk you through a brief outline of how we can use analytics and engagement to help drive revenue for media-focused organizations. So the first thing, let's go through a brief agenda slide, a brief outline of what we're going to do today. Today we're going to describe systems and approaches for users and customers to do the following: persisting, capturing and strengthening audience engagement. Because when you can capture that sort of information, it leads to audience stickiness. Brand loyalty is the objective of any media enterprise today, whether they be in next-gen video, starting the new U-Butte music streaming service, whether you're a tabloid media outlet, whether you're doing some sort of ticket or marketplace activity. That brand engagement and driving customers to your website / platform or app is key. We're going to talk about some of the technology approaches, the kind of workflows that we implement utilizing data analytics to drive some of this engagement. We're also going to look into some of the few scenarios where we use machine learning to drive smart recommendation engines, how we make sure that we are presenting the right form of content to users as they use our platform. We also look at how we estimate sentiment and look at how people are feeling about our platform and whether or not we can use that to make good business decisions. We're also looking at segmenting our audience to understand who's using it, where they've come from, what they're doing and what they're likely to do next. And finally, if we have time, we might touch on predicting churn, which is obviously a very important part of the solution set. And finally, at the end, we'll have a bit of time for some questions. So, as you can see, there are lots and lots of information, what I call engagement signals out there in the marketplace. Everyone is trying to create what we think is the next and best media delivery platform system. There are some what we call real-world signals, indicators, background signals that we can use to help capture, synthesize and make sense of what's happening out there. If you look at Netflix, one of the big things from them is 75% of users on their platform watch recommendations from there. That's a huge number. 3/4 of the people on the Netflix platform are watching content based on recommendations made to them. The second one, Nielsen, and we're going to talk a bit more about Nielsen a little bit later. They work out that utilizing social media activity, in particular tweets, can drive almost 50% higher broadcast TV ratings for content. Now, since a lot of these broadcast TV agencies make their money based on getting viewers to their shows, being able to increase it in almost 50% is huge. The last one from Google means that they can correlate based on search on their platform. They can almost explain a 70% variation in how a movie at the box office is going to perform based on the search volume. So people now, producers of video, producers of movies at the cinema can get a real close estimation about how their particular movie is going to perform at the box office simply based on how often and how frequently it's been searched on the internet. Basically, capturing and using all of this content, creating a conversation and creating snippets of what's going on, really it creates a massive gold mine of data, this kind of treasure of information that media organizations can use to really drive higher utilization of their platform, get greater engagement with their content and drive higher media revenue. A classic example, and I think one that's very topical today, is focusing on the US presidential election. Effectively, in America and the US, this is a real media battle. campaign managers are trying harder and harder to drive the right message to the right part of the voters with a targeted message. Nielsen's is the single biggest producer of media metrics. They really understand the size of the market, the composition of that market. When you overlay that information about media metrics with the voter information that the campaign managers can bring to the table, it creates a powerful methodology for people to target the right voter segment with the right message on the right medium. People of today don't always just watch TV. It's a combination of TV, radio, and multiple different digital outlets. Utilizing these media metrics, you can work out what is going to be the right platform to create the right message for the right voter segment, and then target that particular segment with that message. Then on top of that, you can mine their opinions. You can look at the sentiment to see just how effective your politician's message is being received, or how well the opposition's being received. And it leads to this ever-changing, ever-evolving market where people are constantly having to anticipate what their change is going to be, change their message, and change the medium which they're going to deliver that message in this, what can I say, this media battle that's going on in the presidential election. So it's a very classic use of how people are using metrics and media metrics to drive media outcomes for their users. So what are these signals? They're very different types of signals, of what I like to call touch points. This is the indicators of what users are thinking, how they're behaving. What we want to do is leverage them to build out predictions. Basically, we're trying to anticipate what the customer needs. Roughly, when you lay it out across a spectrum from behavior through to transaction, we'll see all the different types of signals that we can capture and use. On the left, we look at transactional signals. These are things associated with what users are doing on a media platform. If we look at the first column, it's what people are doing if they're clicking on a particular web stream. What they're doing with their player? Are you pulling information out of OLTP or database sources? These are classic examples of creating a lot of rich content about what users are playing, what they're searching for, what are they adding to a playlist, or what are they subscribing or paying for. In the second column, we have more service-orientated transactions. So what you're trying to do is capture the kind of behavior users are doing on your platform, whether they're contacting sales to try and upgrade their platform, are they subscribing to a platform, are they contacting support because they've got a problem, are they complaining about if their player is buffering and so forth, are they, in the worst case, are they thinking about cancelling that subscription? These are all really good transactional information that you can collate and then build prediction models to kind of capture what the user interest is. On the right-hand side, we've got more of the behavioral signals. These tend to be mostly related to social media space. For example, if I watched a bit of media content, I may have tweeted about it, I may have rated it, I might have watched this movie and said this movie is worth 3 stars. I might have shared it. I might have gone onto some sort of social media platform and shared that particular movie and my rating of that with people within my network. These are all really good social behavioral signals that we can collate together to then create what we believe to be the mood, the desire, basically what users are thinking about and how they want to behave. Somehow we need to make sense out of all of this. So let's look at from a technology standpoint. What we can use is analytics to get to the heart of many of these types of problems. There are 3 types of analytics that we wanted to talk about today. The first one is descriptive. This is one that's been around for many, many years, and it's probably what most people already know. It's very, very common today. It's about taking information and storing it into things like data warehouses, into your standard kind of BI environments, and then running things like Hadoop, collecting it, summarizing it, and basically providing metrics on basically what has happened or what has happened in the past. From here, we're able to kind of create and position things like dashboards to see what has happened or what has just happened. If it was like a countdown, think of this like T-5. The second one down, and one that we're going to spend a bit more time on today, is the predictive analysis. If the countdown, if descriptive was t minus 5, think as predictive as t plus 5. We're trying to ascertain what are the things that's going to happen after next. What can we do to make sense of all of that data that we have and build out patterns to identify what will happen next. What we want to do is wrap that up in a whole heap of cool technology to apply to use cases today. And in this field, what we're really using is machine learning to create that, to take all of that huge data set to basically ascertain and predict what's going to happen next. The last field in this analytic spectrum is prescriptive, or the emergent field. It's been around for a few years and has gone under many, many names. But essentially, it's taking all of that predictive information and then making a decision on what I should do next. If I am predicting that a user is going to do X, then maybe what should I do? Should it be Y or should it be Z? We're not going to focus on that area today. There's other people within AWS who can go into more detail on that, but that is very much an emerging part of this analytics spectrum. So, using machine learning, it's the key for being able to do this predictive analysis. So what is machine learning? For those of you who don't know, it came about in the 50s. And literally it's about applying statistical, mathematically, and probability and using computing-based packages in order to do that. Machine learning has not really been possible because most people could not get access to the computers to do the learning. With AWS, this has become more possible. It has allowed people to utilize this technology and apply it to use cases like media to really get some great outcomes. What we're looking at doing is making sense of large volumes of data, generalizing the data coming in, creating patterns and models for future behavior, and then using maths to predict future events. Today I'm going to talk at a really high level about all of the machine learning, but across the entire gambit of AWS and Asia, there are many people whose sole purpose in life is to focus down on machine learning, and if you want to get more data, you should reach out to one of those guys. But what people need to understand is most of the media organizations who we are using today are all using machine learners in earnest and are using that to get some really good media focused outcomes. So what are the tasks that they're doing? The first one is probably the most obvious, and it's one that probably most people have some visibility of, and that's recommendation engines. I use recommendations and related content very closely together. Essentially, it's about understanding what is the next best media asset to present to a user once they have done something. For example, if I've watched a movie, if I've listened to a song and so forth, what would be the best recommendation for that particular user to go to next? The second one is clustering. Again, it's something that's emerging in the machine learning environment, and it's all about giving computers a massive data and allowing them to identify common groupings in the data, essentially patterns in the data set from which you can make categories from which to put into users, and then for you to then do a specific task to target that particular user. For example, if I've got a huge subscriber base of people who are utilizing my video on demand platform, clustering them into different situations to know what type of user that is, I can then target them with specific marketing type activities to either get them to do something different or in one case prevent churn. The final area is classification. This is the big giant area of machine learning. It is predicting a certain set of values in a data set, predicting the price, for example, predicting the price for a given product, given the historical purchase patterns over years and years of data. Essentially taking the guesswork out of being able to use that clustering and recommendation information to make a really bona fide guess of what we should do next. All of these different tasks together do not give you the final answer. What they do is it allows you to add this to your other business-focused information for customers to then make really good decisions. In all of these three task area, there are lots of different technologies, there are lots of different algorithms, lots of different ways for people to get to that end result. In order to achieve that, what you need to look at is engaging with partners and data scientists who have the ability to look at these different tasks, look at the different options available, and then recommend what's going to be the best one to get the outcomes that you're looking for. The question always comes down to why would you want to do this in the cloud, and I'm hopefully a bit later on I'm going to talk about some really good use cases about how the cloud has enabled this to happen. But the ability to do this stuff at scale, do it quickly, being able to try new tools, try new techniques, give this technology to people like data scientists and partners to quickly establish what is a good environment, what is a bad environment. If it fails, getting rid of it, tearing it down and starting again. Having that agility to be really flexible with what you're trying to get from your data sets is only possible in the cloud, and AWS is leading that charge. For example, what I'm going to do is present a little example from a customer in India where they're using all of this engagement signals, all of this background information, transactional information, behavioral signals, crunching it into a data set and using that to understand how their customer acquisition is going and churn, looking at how their content is performing, monetizing their content and generating more revenue, looking at the subscriber base. What you can see here is the amount of traffic over time. A better example of that is a dashboard that they provide to their particular customer where they can quickly and easily see what is happening on their particular media platform in a blink. Who's on the platform, what devices are they using, how much have they paid, how much have they churned, what active users we got on there. Taking all of this information, both transactional and behavioral, and giving you a single dashboard of what's happening in that media environment. Very powerful. So what is the technology that we use in order to create those types of dashboards? Well, there are many tools out there. It's a huge ecosystem of products and services that users can use. There are lots and lots of tools, lots and lots of products, tons and tons of choice. What I like to say, there is just a huge amount of opportunity for data scientists and people in this BI space to play with technology and work out what works best for them. There is no single one thing you need to use, there's multiple. However, the one thing about AWS, it gives you access to this ecosystem. It makes it available for customers to really dabble their hands in this market, see what information and what nuggets of gold they can get from their database, and then actually use that to make really good business decisions. So what I want to talk about now is kind of throw in there some what I call media scenarios that occur often in the media space. So the first one we're going to probably talk about today is recommendation engines, recommending products. You know, if I pick a movie, what item am I going to present next to that particular user? Will it be based on similar users to that one user? Will it be based on similar items that I've utilized? The next thing I'm going to talk about is actually taking some of that recommendation engine and using that to basically anticipate where my demand is going to come from, and then pre-stage that media to bring it closer to that user so that user experience is better. Other sample media scenarios that we're seeing in the marketplaces, people are using this type of data to help them understand what's going to be the best CDN to use. In many countries, there is no single CDN that's going to provide you with the best outcome for all of your customers. Sometimes you want to be able to mine that data, mine that sentiment, and maybe make a CDN selection based on that information. The final piece that we're going to really dive into is this thing about ad targeting campaigns, segmenting your customers, understanding what they're doing, understanding the sentiment out there, and then changing the marketing message to understand what's the best way to get that message to them. Another use case that we won't go into today is probably in game developments. Most of the games on the marketplace are now online, and what we are looking to do is make sure that you're providing a wonderful experience for all of your gamers. If you can look at your classification of customers and you can see there's a section of that are not enjoying their gaming experience, being able to pivot and change and make improvements to help them will ensure that you'll keep those customers online for longer and obviously generating more revenue for yourself. And the last one, we talked about before, was predicting audience churn. So, recommendations. how do we do it? Got a real understanding about recommendation engines. Most people have had some sort of touch and play with video streaming services such as Netflix or Amazon Video, iFlix. There's quite a few of them out there. It's essentially of understanding if a user picks an item, what am I going to recommend next? You know, what we want to be able to do is make sure that we're presenting options and services to which that user will want to connect to, so that they increase their usage on the platform, stay on the platform for longer, and really enjoy that platform, and then talk about it to their friends and neighbors and people within their circle. In order to try and do this, we need to use machine learning. And the granddaddy of machine learning is Mood. It's been around for a long time, and it supports a large number of algorithms. It's an open source platform. It originally came from the Search Engine Project, which was focused on finding related items in a search operation. It has really grown up today. It's moved from a single node to being now a multi-node distributed environment. In the past, it's been very focused around MapReduce, but that tended to be a little bit slow in this kind of fast-moving, needing to get information back to users quickly environment, and it's soon morphed to being using Apache Spark. So what is the concept of recommending recommendations to users? The first thing we want to do is we want to capture all of that signal data. You want to capture all that massive information related to users picking media. The next thing you want to do is estimate the cohorts or the groupings who are similar to me. Basically, people who are accessing content very similar to what I would be selecting. This could be media, TV, songs. If you're using it for buying items, you know, you're looking at what they've picked and put into their baskets, what they searched on. Next, you want to record all of this goldness of information and put that into a search engine. And then you want to be able to use this search engine to continually deliver updated search items to the users. So what happens is, as a user's on your platform and moving around, you want to be continually updating, giving them better and better recommendations, items to buy, and so forth as they go through life on your platform. Then at the end of it, you'll have a user that's really enjoying all of their recommendations, and you'll get to that position like Netflix, where 75% of all of the content they watch is based on the recommendations presented to them. So here's a kind of a quick example of how that would work. Here on the screen, there is a view from, say, like a digital archive. So imagine if I was logging into this digital archive, this video platform for the first time. What you have here is what we know as a cold start problem. They have no history on me. They don't know what I've picked in the past. They don't know what I've done in where I've been before. So what you have here is an environment where we probably have some sort of editors who've basically selected the hottest trending films, the hottest films that are available, the kind of things that people have been selecting, and they'll put that in that first opening screen, what I like to call editor's picks. Then, let's imagine I'm the user, I'm feeling today's a good day, I want to go and watch a real golden oldie, I want to go watch Wizard of Oz. So then I would select Wizard of Oz. Now at the bottom corner of that, you can now see items that are being recommended to me. These options are basically what we like to call related options. So it's basically when people have, using the history of information, some of that transactional information, people who have watched Wizard of Oz, this is what they've also watched. So basically it's just a history kind of laid out in a bit of relevance. Now, in the background, what's going on? How are we going to build up this recommendation engine? What we want to do is collect all of that log information. An example before, me clicking on that movie, we want to collect all of that log, that history of information, and we want to articulate that. We want to sessionize it, we want to normalize it, and we want to get it into a history matrix. So in this example, we've got Mike, who has selected Star Wars Episode 5, or John, who selected Highlander. We want to store that in a history matrix. Then we want to transpose that matrix. We want to get an item-to-item matrix. It's kind of like a statistical probability issue. What we want to see is objects that were seen in someone's playlist that also appeared with other objects. So if Mike had been watching Highlander before? Had he also watched Star Trek and so forth? We want to make sure that we count the amount of times these similar items have appeared, and then make sure we collect that data and present it in this item-to-item matrix. Then what we want to do, step 3, is reduce it. We want to reduce it into pairs. Right? Again, it's a math strategy. What we want to do is what we want to do in reducing this is we want to remove the obvious pairs. People don't want to be presented with obvious options in the recommendation. They don't want to have the same movie appearing over and over again. They start to feel like that's just taking them a little bit for granted. So what they do is they use LLR to reduce this to interesting pairs. LLR stands for log likelihood ratio. It's a technique that we apply, and that removes all of the common co-occurrences. It removes anything basically that's not interesting, and it removes, and what it leaves you with is interesting pairs, what we call the gems. The thing we feel like to watch. It creates elements that are similar to what I'm watching. So in selected Highlander, what it's done is reduced all of the obvious pairs that go Highlander and everything, which would be Superman, and that will be placed at the top of my recommendation engine. So step 4, what we're doing. So what we've done is we've taken all of that information, all of that backing about, and what we want to do now is store that in a fast cache. This is not a relational, it's not elastic cache. What we want to use is something like cloud search. This is a distributed system which gives us real good search engine capability. So what it's doing is it's taking all of that really cool, appropriate information, all that information selected, movie A, this is related to movie G, H, L, and R, and it will index, which means that we're giving users a sub-second response time to go search that, ability to do content and metadata search, which means then I can then present users back recommendation engine based on my selections previously. Giving you a quick walkthrough, imagine this is my browse history. I go and select a movie. I'm a Star Wars fan, so I select Star Wars episode 4, sorry, episode 5. I then select the next movie, which is Highlander. We then take all of that information, all of that movie playlist up, we present that up, and it generates a search query. Previously generated batch information that's been loaded up into cloud search. From there, it will then return, say, having selected movie 12, it will then give you the recommendation of the next, and that's how we get a recommendation engine working for. So what's the logical architecture? What does it look like? Or architecturally, have a user front end where we're collecting all of that log data that gets storage environment. Then we have a background operation that will perform sessionalization log of that log data. Then what we're doing, we're turning all of those items into matrix that we spoke about before. Who selected what is the likely pairs. Then we have that engine, and that recommendation engine gets updated with the next bit of information, so that the next time a user goes in, we then give an updated return on what is the best recommended product. So under the cover, what it looks like. So this is a bit of an older event for us to use today. We have a Beanstalk web front end, which pushes for log data storage. This is ingested into an ETL pipeline. Here we get data, we inject it into a form that's capable of being walked through by EMR Mahout. We then finally pushes these batch calculated matrices into a fast catch into our index, and from here an environment that can be sent back to customers. Now, to make that element. What I will say is that we wouldn't necessarily use CloudWatch. A lot of what we're doing today, so please don't think of that as the only way that you can do that, but it's a good starting point. Making it easier for customers and users to be able to create this environment by having everything you can simply click on the parts of EMR and Mahout that you want and quickly get started in complex steps out of it. What you end up with is a recommendation and every other movie that's associated with it, created within 10 minutes of ingesting all. In front of you here is a example from an Indian tabloid. What they wanted to do was improve their user experience, and what they wanted to do was created content which is very similar to recommending content. They wanted to create those widgets, basically, which is on the right-hand side. This technique, what we talked about earlier, allowed them to achieve three things. First, users coming to the website, it's easy for them to find other content that was similar to what they're looking for. So if they searched, found this particular item and it wasn't the item they were looking for, it allowed them a quick and easy way to see other content that was related to it. Second, it made it easier for people who then read the article to then read similar articles along the same theme. And third, it allowed users who were on the platform, having read a particular story, to go and find other stories on the platform that they're looking for. Essentially, it really made it easier for the newspaper, the tabloid, to present better options to their users to improve their experience on the website. And as a result, what you saw is a very quick improvement in all of the metrics that we're looking at. 20% increase in traffic. 40% of the story traffic came from the related content widget. Bounce rates dropped, and bounce rate is how many times people were bouncing around trying to find the content they're looking for. That's a huge drop. And then how long people stayed on the platform increased by over a minute. This is all incredibly important because the longer they stay on your platform, the more information you can gather from the users, the more data you can present to them, and also the easier in which you can target them with specific ads. So we've talked a lot about the use case around recommendation engines. Let's talk about the second use case, which is estimating sentiment. So what we're looking at is trying to take the pulse of the audience and then allow that to have an effect on our recommendations and our digital marketing. So what we're looking at is using machine learning to capture that user sentiment. So what we want to do is we want to capture all of those signals from social media. We want to use near real-time streams such as tweets and comments. We want to capture and ingest all of that information into some sort of engine. We want to apply machine learning. We want to extract the keywords and tokens. The key things that people are talking about a subject, they like, they hate, it's annoying, it's not annoying. And what we want to do, we want to be able to apply previous knowledge that we know about what constitutes a positive and a negative and apply that to that particular tweet, that comment, or whatever it might be. And from that, we can churn out a running aggregation for what the trending temperature for a given subject or topic or theme would be. Such as if there's a movie, are people talking positively about it or talking negative about it? Or as the example I used earlier in the US election, you want to know as a candidate is speaking about a particular subject, is the mood improving, is it decreasing, do we need to change the message, that kind of thing. Okay. So here, this is this slide's a bit old, taken from a couple of years ago, but what you see here is people talking about the trend on whether or not Star Wars, particularly episode 28, was a positive or a negative thing. Now, in the pie charts, you can see whether or not it's been considered negative or whether or not it's been considered positively. If we were to basically roll it out from what happened a couple of years ago, this actually does trend eventual green, but you can see in that graph on the top right-hand corner that as we are monitoring what's being said on social media, we're actually getting a nice little graph to show us how the sentiment of the users is being evaluated to say whether or not this is a good thing or a bad thing. As I said before, we cannot use this data alone. It's very much an estimate of the feeling out there. But what you can do is use this data with other data sources like your transactional behavioral signals to make really good business decisions about what we should do next. So what does it look like? So we go back to our architectural diagram. We have exactly the same situation that we had earlier, but now we have two different input sources. Now we're going to be collecting beacons from other sources. So a beacon, for example, could be the CDN logs to see what people are doing, how long they're on a particular website, what they're doing on those websites. Beacons also is like some of the data that's coming off players. So a lot of players will beacon a lot of information about how long people are watching content for, where they're watching up to, did they stop at one particular point, and so forth. I mean, adding all of that to that other log information that we collected earlier. And at the bottom, what we've got now is we're collecting all of those social media sources. And then we're going to put that through some sentiment processing, and then we're going to add that into our recommendation mix. So what does it look like? Essentially, it's the same diagram as before. We've just got some more information going into the bucket at the top. Again, we could be utilizing things like Lambda to help with this particular function. But at the bottom, we're utilizing third-party social media brokers like GNIP and DataShift. These guys, we can collect, they aggregate all of those social media feeds, allow us to process that signal information from social media, and then add that into our mix. Most of these guys actually do have an API to Firehose Kinesis, that we can take all these feeds from. And what that allows us to do is immediately inject all of that information into our processing engine. From there, we can extract the features, say, from every tweet. We want to extract those keywords. I loved it, hated it, adored it. We want to extract any sort of images, any emoji, any smiley faces or negative faces, and then classify that based around previous knowledge that we have about what is a positive and what is a negative tweet. At the bottom, we also have like a model training. Think of this as a corpus of information, of evidence, where we bring all this information in and we basically decide whether or not this is a positive or a negative outcome. The more information that we put into that model training, the better we can in accessing whether or not a tweet is actually positive or negative. All of that stuff basically allows us to then produce, in the top right-hand corner, what is the trending sentiment for a particular topic at any one time. So if we go back to our original example of when we are selecting information for a user clicking on the movie title, what we now have is this wonderful kind of decision tree. At the top, we have no recommendations, so cold start. You might put some editorial information. Then I might go and select a particular movie. Now we're going to do some kind of value matching, some description matching, and we're going to give a whole heap of items based on what we know about one user picking that particular item and creating another item. Now we can run this through our Mahout recommendation engine, which now applies all that log information and information from other item-to-item matrices to now understand what's going to be the best recommendation to present to that particular user. In this case, it could be Milan. Then, let's just say in that Mahout recommendation engine, I might have a whole heap of different types of movies, but I want to filter on movies for my children, so I want to only have animation movies. So then we can apply a genre filter, and then we're now going to be removing all of the other titles and only presenting options that are animation. And at the end of it, we can now put in there all of that sentiment data. So we can push all that sentiment data in something like a DynamoDB, and when our recommendation engine is looking to present options to present to me, it can add that into the mix and then move titles up and down based on the trending sentiment from the viewers out there about whether they like or dislike a movie, and then we get the right choice for ourselves. So in this case, Milan might get moved down because, for the last couple of weeks people haven't enjoyed that particular movie. So what we get from before is basically if I select a movie, we just get a whole heap of random titles that have no relevance to what I originally selected, which is bad, and it's never going to keep them on the platform, and it's going to annoy people to bingo and be able to use machine learning to present option based on sentiment, based on items matrix, which is basically going to give a positive result and more likely to select that title and stay on that media platform. What else can we do with this kind of information? Well, essentially, data, what I love to say is broadcast media haven't made the transition to the newer forms of TV. They're not yet presenting things in 4K or HDR. And more people are moving to things like OTT platforms and that in order to get access to that type of video content. The problem with this is that those video content, those files are big. So what we want to be able to do is use all of that rich information that we had earlier, all of that recommendation information, all of that trending information, that sentiment information, and understand what movies and what formats are going to be viewed by more people ahead of time. Then we can take proactive measures to move that content closer to the user, so when that user starts on that particular type of content, they don't actually have to wait for buffering.